What do we know about fractions that we're adding? What do we need before we can add
Common denominator.
a common denominator? So what common denominator do we need in number 1? 20. If you can't think of one, you can always multiply them together. And that'd be a good denominator. 20. All right, so what do we need to multiply by 4 to get 20? 5. So if I multiply the bottom by 5, what do we need to multiply the top by? 5. So 5 times 13 is? 15. This fraction is equivalent to 3/4. If we were to reduce it, they're the same number. So did I change the value of 3/4 or did it change the way it looked? Change the way it looked. Okay? It's still 3/4. It just looks a little different. What do we need to multiply by 5 to get 20? 4. So I'm going to multiply the top and bottom by 4. What's 2 times 4? 8. When we add fractions, we keep the bottom. We never do anything with the bottom. But the top, we do 15 plus 8, which is 23. It's okay. We just had lunch. Can I reduce? No. If I could reduce, should I reduce? Yes, always reduce in math. So we have 23 over 20. All right, our next fraction. I know that there's a second way to do this, and some of you probably did it that way, which is fine. But I'm going to do it the fraction way. What denominator should both of our fractions have? 5. All right, so looking at the number 1, what denominator does it have currently?
1.
It has a 1. What do I need to multiply by 1 to get 5? 5. So multiply the top and the bottom by 5, and I get 5 over 5. Is 5 over 5 equivalent to 1?
Yes.
Show is. Do I need to do anything with 9 over 5? No, it already has a denominator of 5. 5 plus 9 is? 14 over 5. Can this be reduced? No, that's it. All right, number 3, what denominator do we want to have? 14. What do I need to multiply by 7 to get 14? 2. Dose. What's 2 times 13? 26. All right, what do I need to multiply by 2 to get 14? 7. All right, 3 times 7 is 21. What is 26 plus 21? 47. Can this be reduced? No. All right, and the last, what denominators do we want? 56. It's a big number, but we're going to be okay. What do I need to multiply by 8 to get the denominator of 56? 7. So I'll multiply top and bottom by 7. 7 times 5 is? 35. 7 times 8 is 56. So the next fraction, multiplying by 8. We'll always keep the bottom. What is 35 minus 8? 27. Can this be reduced? No. Questions about adding, subtracting fractions? All right. Go ahead and go to the front. We're going to talk about equilateral and isosceles triangles. So, can someone raise their hand and tell me what an equilateral triangle is? Andrew.
A triangle which has all the sides equal.
All the sides are equal. Well, if all the sides are equal, class, what else do we know? All the angles are equal. All the angles are congruent. Good. So this would be equilateral. Can someone raise their hand and tell me what isosceles is? Go ahead, Sam.
A triangle with 2 congruent sides.
A triangle with 2 congruent sides. So if we have 2 congruent sides, we have 2 congruent angles. So what you're going to learn in this class is we're going to be given numbers of sides and angles, and we're going to solve things based on that. The isosceles is what we're going to be talking about first. If you see at the top of your notes, there is an isosceles triangle. First thing that we're going to do is fill in the blank in our notes. So I'll highlight what you need to write down. A triangle is isosceles when it has at least 2 congruent sides. That's actually the first blank. I know it says side, but everyone, as the great Hannah Montana says, everyone makes mistakes. That was nothing. I get anything for that. That was a cultural reference and everything. What? There you go. So has 2 congruent sides. All right, so if you look, these 2 congruent sides are already marked. What do they say that we call them on my picture? We call them legs. Just go ahead and write it in leg and leg. So my two, hopefully you're following along with what I'm saying, not just trying to fill in the blanks. I'm going to help you. The two congruent sides are called legs. All right, so when an isosceles triangle has exactly two congruent sides, these two sides are called legs, like we just said. The angle formed by the legs is called the vertex angle. So you're going to label this angle up here your vertex angle. Vertex angle. So writing over here, leg, vertex angle. And this blank is vertex angle. All right, the third side is called the base. So down here is called the base. All right, and the remaining two angles we call base angles. So the two angles adjacent to the base are called base angles. So your last blank is here. All right, so you're going to take out your highlighter. I'm going to tell you some things that you need to highlight and remember. You're going to write down base angles are congruent angles. Base angles are congruent angles. Base angles are the congruent angles. So the important part about this is knowing which one is your vertex angle. Your vertex angle is the angle that's kind of like the odd man out. The base angles are congruent to each other. So these two will be the same number. The vertex angle will be a completely different number. The reason that this is important, and I just picked them off the printer, it'll have a sentence. One of the base angles of an isosceles is 42 degrees. Find the measure of the other angles. Well, if you know that one of the base angles is 42, what's the other base angle? 42, because they're congruent, which means you could find the vertex angle. So it's highly important that you remember the base angles are going to be the same measure, and the vertex angle is not. Okay? So we're actually going to talk more about this right here. Well, after I show you everything again. Ta-da! Here we go. Base angle theorem. It's in the center of your page. You're going to see there's a big blank. You're going to fill in the blank. If two sides of a triangle are congruent, then the angles opposite them are congruent. You're going to fill in the blank if AB is congruent to AC. So you're filling in the blank, what I've highlighted. If AB, side AB, is congruent to side AC, that means the angles across from them are going to be congruent. So let's start with AB. AB. What angle is directly across from AB? Anybody? Just one letter. C. So angle C is going to be congruent to another angle. Let's find the angle across from AC. What angle is directly across from AC? Angle B. All right, so that means angle C will be congruent to angle B. All right, the second, you're going to go ahead and write down in that box if angle B is congruent to angle C. We're just doing it again, but this time given angles instead of sides. What side, because if angle B is congruent, that means a side is going to be congruent to a side. What side is across from angle B? AC. So that means AC will be congruent to another side. What side is across from C? AB. Ta-da! All right, so we're going to do the problems at the very bottom. You got two of them. Would someone like to read the directions for me? Go ahead, Noah. Read the directions.
base angles theorem and
Yep, that's fine. Just right here.
and triangle DEF, line DE is congruent to DF. Name two congruent angles.
Name two congruent angles. Perfect. So DE is marked congruent. What angle, class, is directly across from DE? One letter, F. Angle F. You name an angle with one letter or three letters. Not two. Just one letter or three letters. So angle F. Our other side, marked congruent, is FD. What angle, one letter, is across from FD? E. So that means angle F is congruent to angle E. All right, so notice, these are technically called my base angles, right? My base angles are the congruent ones. When we think of base, we usually think of the bottom, right? The base of something is usually the bottom. In this case, it's not necessarily true, okay? Because F is definitely not on the bottom. So don't let the word base throw you off. The base angles are just your congruent angles, okay? Let's look at the second. We're going to instead name two congruent sides. So we have, let's start with angle B. What side is directly across from angle B? Side. Yeah, CA. We could say CA. All right, and then angle A is marked congruent. What side is across from angle A? CB. So that means those two sides are congruent. If you have no questions, go ahead and flip to the next page. Does anybody have a question? All right, let's do this. So here is where numbers come into play. These top two will be very similar to the ones on your quiz or test. They're fairly simple. Number one, what kind of triangle are we looking at? So isosceles. All right, I know I have two congruent sides. So that means I have how many congruent angles? Two of them. The angles across will be congruent. So let's see. What angle is across from the one I've just highlighted? This blank one is across. So it's going to be congruent to another angle. All right, and the other side marked congruent is across from what angle? X. So that means, what is my missing angle going to be? It's going to be X. We're going to solve. So we have X, 130, and X. They're all three angles. What do we know about the three angles in a triangle? They add to 180, so let's add them. 130 and X will equal 180. So we have 130 plus, what's X plus X? 2X equals 180. Subtract 130. And 2X equals 50. Divide by 2, and X equals 25. Questions, comments, concerns? Okay, let's look at the next one. How many congruent, well, first off, is X a side or an angle? A side. It doesn't have a degree symbol. Okay, so it's a side. All right, we have some things marked congruent. Do we have sides or angles marked congruent? Angles. So if we have two congruent angles, we have two congruent sides. And the sides across will be congruent. So if the sides across will be congruent, what do we know about 3 times x plus 2? It is equal to 24. Because those sides will be congruent. So let's solve that. 3 times x plus 2 equals 24. All right, what do we do next? We're on this one. Distribute. So 3 times x is 3x. Most common mistake on the test. Have I finished distributing? No. Please tell me why we stopped distributing on the test. Distribute 3 times 2, which is 6. Y'all know how to do it. Equals 24. How do I continue to solve? Subtract 6. 3x equals 18. Divide by 3 and x equals 6. Ta-da!
But when you plug it back in, it doesn't equal 24.
It sure does. 3 times 6 plus 2. You do parentheses. 6 plus 2 is 8. Good point. And it does equal 24. That was also a common mistake when people plugged back in. You got to do your parentheses before you don't distribute. All right, this next section you want to label equilateral triangles. Equilateral, equiangular triangles. So where it says corollaries, you want to write equilateral triangles. Equilateral. Equilateral, equiangular. We've actually been saying this since day one. If a triangle is equilateral, then it is also equiangular. Look at that. So you have an entire box that is blank for you guys. You can write it. If triangle is equilateral, then it is equiangular. Which makes the vice versa true. If a triangle is equiangular, then it is equilateral. Then I'm going to give you two things to write down after and then highlight. So if a triangle is equilateral, it is also equiangular. If a triangle is equiangular, it is also equilateral. They go together. So what you're going to write down, put a little asterisk. Okay, in these, all of the angles are how many degrees?
60.
Are 60. If all the angles equal, how many degrees fit inside of a triangle? 180. Okay, let's say Grandpappy dies and he has $180 to his name and he wants to split it between 3 grandchildren. How do you split 180 between 3 people? Divide by 3. That's 60, 60, 60. All right, so all the angles are 60. All right, and then all the sides are congruent. Does that mean all the sides are 60 degrees? Is that possible? Are sides measured in degrees? No. So sides won't, 60 and sides, they don't go together. The angles will be 60, but the sides won't necessarily. All right, let's move on. Hopefully you wrote that down, maybe highlighted it. We're going to do the next section. The next section is 1000%. This exact problem is on your quiz or test. And both. I don't know if you want to say and. The numbers will change to protect the innocent, but everything else is the same. So if you want to highlight that or maybe put a star next to it, because you will see this again. So if we look, we have one triangle next to another. We agree? All right, so what is my left triangle? What kind of triangle is this? Equilateral, equiangular. So what I'm going to do is I'm actually going to write in 60, 60, 60 just to remind myself. What's the measure of each side? 4. So if each side is 4, what does y equal? 4. I didn't even have to do anything. Y equals 4. Did I finish the question? No. But a key to doing well in this section is filling in the information you know. I wrote in all the 60s. I wrote that all of the sides are 4. Let's look at the next triangle. What kind of triangle are we dealing with here? Isosceles. It is going to be obtuse. So, pause and question. Why does this left portion have 1 curved mark and the right portion has 2?
Because
They're not congruent. They're not the same. So all of the one with 1 tick mark, all the 60s, those are congruent to each other. And then the angles with 2, those are going to be congruent to each other. It's very important to know the difference. So let's see. We have 2 congruent angles, which means we're going to have 2 congruent sides. So let's find what the 2 congruent sides will be. All right, let's see. What is across from angle N? x plus 1. So it's going to be one of my congruent sides. What is across from angle M? ln, which is 4. So that means what does x plus 1 equal? 4. All right, so what does x equal? 3. Ta-da! Promise you'll see this problem again. All right? We're ready to go to the next one? Let's do it. Here we go. Number 3 is probably as hard as they come. What kind of triangle is this triangle altogether? Equiangular, equilateral. Okay, so let's go ahead and mark that all the angles are equal to 60. It's always important to write in all the information you know when you know it. So does x equal 60 degrees? No, because x is only a part of this little sliver, and we'll get to that. I think the easiest thing to find would be the sides. What's going to be the measure of all the sides? 46. Which means this one's 46. So is y a side or an angle?
Side.
It's a side. We know that from here to here is y, from here to here is 16. How could we find out what the measure of y is?
46 minus 60.
We could subtract, and we'd get
30.
30. So y equals 30. So here's what you technically did. Y equals 30. The math version to do this. The length of this entire side would be 16 plus y, and it equals 46. You just did this in your head, but I'm just showing you how to do it algebraically. All right, and then you subtract 16, and y still equals 30. So we found y. We need to find x. So here's what I tell people to do. Let's find out exactly where x is. X is this angle, yes? We all agree? RJ agrees. Anybody else agree? All right, so what I tell people is to look at the triangle it's a part of. All right, we're looking at a triangle. I highlighted in pink. Is it highlighted enough for y'all? Hope so. So we know we have x. We have 60. Could we find our third missing angle? We could. What relationship does our missing angle have with 80? They're a what? They're a linear pair. This angle and this angle are a linear pair. What do you know about linear pairs? They're supplementary. They add up and equal 180. So if you already have 80 degrees, how many is left for the other portion of the angle? 100. So now we have 60, 100, and x. So how could we solve for x? Add them and then subtract. So let's do it. 160 make 160. Subtract from 180, which is 20. So x equals 20. So again, this one is probably as hard as they come. Questions, comments, concerns? Okay. We do the last one. Again, this one you will see mostly on the homework tonight, but you will see it again. Let's look at the top triangle. What kind of triangle is this top one? Isosceles. Which means we have how many congruent sides? 2 of them. So that means this other side is going to be 20. What other thing do we know if we have 2 congruent sides?
2 congruent angles.
2 congruent angles. So we need to look at the angles directly across from my congruent sides. So this bottom corner is across. Oop. And then the top corner is also across. So what is this bottom corner going to measure? Yeah, x. 20 is it 20 an angle? 20 is a side, so that it won't equal 20. It will equal x. The 2 angles will equal each other. All right, do we know the measure of this angle up here? We can. Let's look at this triangle for a second. Kind of have to hop around. What kind of triangle is down here? Equilateral, which means all the sides are 20. They're all congruent. So all the sides are 20. So we could pause and find the side, can't we? So we would know 5y equals 20. So what does y equal? 4. While we were there and it was just sitting there. Y equals 4. All right, now let's find our x's with our angles. If it's equilateral, it is also equiangular, which means all the angles equal what number? 60. So I'm going to erase my sides for a second. All my angles are 60, 60, 60. What relationship do these two angles have together?
Linear pair.
They're a linear pair, which means they do what? They're supplementary. They add up and equal 180. So what will the other angle equal if we already have 60?
120.
120. Now we have 3 angles in a triangle. So can we solve? Yeah, we got 120. Now 120. And we have x and x. And they equal 180. So we have 120. What's x plus x? 2x. They equal 180. What do we do from here? Minus 120. So 2x equals 60. Divide by 2 and x equals 30. Questions, comments, concerns? All right. So let's talk about your homework for a second. So what did I do on every single problem that helped me solve it?
Found out what triangle was.
Find out what kind of triangle it was. What else did I do?
Write in your measurements.
I wrote in my measurements, right? So what you're going to do for your homework, I know I don't usually require it, but for this homework especially, you will have to draw the figures. Because half of it, I'm going to take yours, you did a good job. Half of it you're drawing on the picture, right? Like that's how you solve it. So in order to draw it, or he highlighted something, that's great. In order to do that, you can't do that in the book. So you're going to have to copy over. So on your paper for your homework, just put it on top of the textbook and copy the picture so that you can draw on it. Okay?